Let's systematically compare analogous letters in the Greek and Latin alphabets. The aim is to provide context and clarity for modern mathematical notation. Starting from the 22 letters of the Phoenician alphabet, we will introduce the letters of the Greek alphabet, including some archaic letters. Then we will compare the Greek letters to their Latin counterparts. The first letter in the Phoenician alphabet is Aleph. Aleph corresponds to the Greek alpha. This is the uppercase alpha, and this is the lowercase alpha. The uppercase alpha can also be called the capital version of alpha. The second letter in the Phoenician alphabet is Bet. Bet corresponds to the Greek beta. This is the uppercase beta, and this is the lowercase beta. The third letter in the Phoenician alphabet is Gimel. Gimel corresponds to the Greek gamma. This is the uppercase gamma, and this is the lowercase gamma. The fourth letter in the Phoenician alphabet is Dalet. Dalet corresponds to the Greek delta. This is the uppercase delta, and this is the lowercase delta. The fifth letter in the Phoenician alphabet is He. He corresponds to the Greek epsilon. This is the uppercase epsilon, and this is the lowercase epsilon. The sixth letter in the Phoenician alphabet is Waw. Waw corresponds to the Greek D gamma. This is the uppercase D gamma, and this is the lowercase D gamma. But this is not the only Greek letter that corresponds to Waw. Waw also corresponds to another letter which we will see later. In the seventh position, we have the Phoenician letter Zayin. Zayin corresponds to the Greek zeta. This is the uppercase zeta, and this is the lowercase zeta. The eighth letter in the Phoenician alphabet is Het. Het corresponds to the Greek eta. This is the uppercase eta, and this is the lowercase eta. Sometimes this is also called eta. So zeta and eta are sometimes also called zeta and eta. Then the ninth letter in the Phoenician alphabet, that is Tet. And Tet corresponds to the Greek theta, which is sometimes also called theta. This is the uppercase theta, and this is the lowercase theta. So here we have zeta, eta, theta, and sometimes they are called zeta, eta, theta. This letter over here, that's in the 10th position. The 10th letter of the Phoenician alphabet is called Yod. Yod corresponds to the Greek iota, and sometimes iota is called iota. So this is iota. That's the uppercase version, and over here we have the lowercase version. This letter is called Kaf. The Phoenician Kaf corresponds to the Greek kappa. This is the uppercase kappa, and this is the lowercase kappa. Then the next letter in the sequence is Lamed. The Phoenician Lamed corresponds to the Greek lambda. This is the uppercase lambda, and this is the lowercase lambda. Next, we have Mem. Mem corresponds to the Greek mu. This is the uppercase mu, and this is the lowercase mu. Mu is sometimes also called mi. And then we have the Phoenician letter Nun. Nun corresponds to the Greek nu. This is the uppercase nu, and this is the lowercase nu. Nu is sometimes also called ni. So we can call these mu and nu, or we can call them mi and ni. This letter is called summik. The Phoenician letter summik corresponds to the Greek xi. This is the uppercase version of xi, or the capital xi, and this is the lowercase xi. You can also call this letter xi or xi. The next letter, ein, corresponds to the Greek omicron. This is the uppercase omicron, and this is the lowercase omicron. The next letter is pe. The Phoenician pe corresponds to the Greek p. This is the uppercase p, and this is the lowercase p. P is also called pi. So here we have the uppercase and the lowercase versions. The next Phoenician letter is tzade. Tzade corresponds to the archaic Greek letter san. This is what the uppercase san looks like, and we can write the lowercase san like this. But this letter is usually omitted. It is an archaic letter, and it's related to tzade. So tzade and san are counterparts. This tzade is in the Phoenician alphabet, and san is in one of the older varieties of the Greek alphabet. The next Phoenician letter is kof. Kof corresponds to the Greek koppa. This is the uppercase koppa, and this is the lowercase koppa. Next, we have resh. The Phoenician resh corresponds to the Greek ro. This is the uppercase ro, and this is the lowercase ro. Then we have shin. The Phoenician shin corresponds to the Greek sigma. This is the uppercase or capital sigma. This is used in mathematics to denote the sum. It's a summation sign. And then we have the lowercase sigma, like the standard deviation. And this is not the only lowercase sigma. There's also another form, which is the final form. And this is the alternative final form. So these are both different forms of the lowercase sigma. So the Greek sigma, that corresponds to the Phoenician shin. And next we have the Phoenician tau. And the Phoenician tau corresponds to the Greek tau. So this is the uppercase tau, and this is the lowercase tau. So this gives us 22 letters. And each of these have a direct analog with the Phoenician alphabet. Now, the Greek alphabet also has some additional letters that were added to the end of the sequence. The first one we're going to see is analogous to wow. So wow corresponds to digamma, but it also corresponds to upsilon. So we're going to put upsilon down here. This is upsilon. This is the uppercase or capital version of upsilon. And the lowercase version looks like this. So both upsilon and digamma are analogous to the Phoenician letter wow. After upsilon, we have phi. So we'll put phi over here. Phi can also be pronounced phi. This is the capital phi, and this is the lowercase phi. The next letter is chi, or chi. So chi is another pronunciation of chi. And this is the capital, and this is the lowercase. So this is chi, or chi. And then we have psi, or psi. This is the capital, and this is the lowercase. And finally, we have omega. This is the capital omega, and this is the lowercase omega. So we have uppercase and lowercase. So we can call this phi, he, and psi, or we can also pronounce these letters as phi, chi, and psi. So just like over here, we have the option to say xi or xi, and we can also say pi or pi. So this gives us all the letters in the Greek alphabet. Now, there is also a numerical system, which is called an alphabetic numeral system. These Greek letters were also used to represent numbers. And there was an additional letter that was added to the end of this sequence. And that letter is called sampi. So I will write sampi over here. This is one form of sampi. So sampi looks a little bit like this, and it has these two lines coming down over here. So that is sampi. And another interesting thing about sampi is that it is added because we're going to remove this san over here. So san is removed from the sequence, and an extra letter is added to the end of the sequence. So that gives us 27 letters in total. The first 9 letters are used to represent the digits 1 through to 9. So that is alpha to theta. They give us the digits 1 through to 9. Iota represents 10. It's in the 10th position. So the position in this sequence is very important because it corresponds to a numerical value. So then the next 9 letters are the multiples of 10. So here we have 10, 20, 30, 40, and then we skip san and we get to koppa. And koppa is 90. And after 90, we get to rho, which represents 100. And then we have the multiples of 100. So here we have rho being 100, 200, 300. Then we have 400, 500, 600, 700, 800, and finally 900. So that's why sampi is added over here. Because if we remove this san, then we need an extra letter to give us 27 letters in total. And then we divide the letters into 3 groups. So we have the first 9, which represent multiples of 1, the next 9, which are multiples of 10, and then the final group of 9, which are multiples of 100. So that is how the alphabetic numeral system worked. So this gives us all of the Greek letters. Now just make this sampi a little more clear. So we have this sampi that looks like this. In fact, I'll use maybe a different color. Maybe we'll use black just to make this extra clear. So we have this shape and then these 2 lines like this. So this is one way of writing sampi. There are some alternative forms for sampi as well. So it's not used to actually write Greek, but it was an archaic letter that was used in some varieties of the Greek alphabet. And we're only adding it here because it serves as a numeral. So the numerical value associated with sampi is 900. So now let's have a look at the Latin alphabet. So we're going to compare these Greek letters with their Latin counterparts. So alpha corresponds to the Latin A, or English A. So the capital is the same, but the lowercase is different. So this is the lowercase alpha, and this is the lowercase a. So in Latin, this will be pronounced A, and in English, it's A. The Greek beta corresponds to the Latin B, or English B. So we have the capital, which is exactly the same, but the lowercase is written in a different way. So this is the lowercase b. Then we have gamma. Gamma corresponds to the Latin K. K is English C. So you see that the capital is a bit different. So here we have a curve, and over here we have a perpendicular angle. So this is capital C and lowercase c. And in Latin, this will be pronounced K. And K was modified to produce G. G is G in English. So both C and G have a shared common origin. So K and G are the original Latin pronunciations, and this would be C and G in the English pronunciation. Delta corresponds to the Latin D. So the capital looks very different, and the lowercase also looks different. And D is pronounced D in English. The Greek epsilon corresponds to Latin E. Here we have the Latin e, which is the English e. The lowercase is different. So you need to make sure that these lowercase are different. Sometimes the capitals are the same, but the lowercase letters tend to be different. Then the Greek digamma, that corresponds to the Latin F, and it's the same pronunciation in English. So here we have capital F and then lowercase f. Next, we have zeta. Zeta corresponds to the Latin Z, or in English you can also say Z, so Z or Z. The capital is the same, but the lowercase is different. So the lowercase zeta and the lowercase z are different. But one interesting point is that this position over here, the 7th position in the alphabet, was changed. So the letter over here was changed. Z was removed from this position, and G was inserted into the 7th position. And then Z was reintroduced to the end of the alphabet. So this first sequence is the same, but then we have a modified version of C, which was put in place of Z. And then Z was later added to the end of the sequence. So that's why this Greek numeral system is a little bit different. That's because this Z was replaced by a G, and then the Z was added to the very end of the alphabet. In the 8th position, we have eta, and eta corresponds to Latin ha, and ha is English H. So here we have H, the capital is the same, but the lowercase is very different. So this lowercase h and this lowercase eta, they have a very different form. Theta does not have a single letter counterpart in the Latin alphabet, but it is usually romanized as th. So we can write th. So just like in thermodynamics, the th, that's a romanized form of theta. Next we have iota. Iota corresponds to Latin E. Latin E is the same as English I. So this is I. And I was later modified to produce J. So I and J share a common origin with iota, and they originate from this Phoenician letter yod. So we can see I and J present over here. So theta was removed, and then I and J were put in this place. So you can think of as deleting this theta and then shifting this I over here and then putting this J over here. And that gives us the modern sequence of the alphabet. But in earlier versions of the Latin alphabet, there was no distinction between I and J. Just like there was no distinction between the letters U and V, which we will see later. Next, let's have a look at the Greek kappa. Kappa corresponds to Latin ka, which is English K. So here we have K, and the lowercase is different. So kappa and K have a different lowercase form. Just like iota and I, they have a different lowercase form. Now let's have a look over here. Here we have lambda. Lambda corresponds to the Latin L. So the capital is different and the lowercase is also different. And that's the same as the English pronunciation. Then mu corresponds to M. The capital is the same, but the lowercase is different. And nu corresponds to Latin N. The capital is the same, but the lowercase is also different. So mu and nu, they are different from M and N. And we often pair these up, and we use this distinction between the Latin and Greek to communicate mathematical ideas. So we have mu, nu, and M, N. Xi, or Xi, does not have a single letter counterpart, but it is usually romanized as an X. So we'll just write an X over here, like in xylophone. But it's not pronounced like a Xi, like the Greek Xi, it's a xylophone sound. So that's how we will romanize this letter. Omicron corresponds to Latin O, which is the same as English O. And we have the capital form and the lowercase form. The letter pi corresponds to the Latin P, or English P. So here we have the capital P, and then we have the lowercase p. So usually we will call the Greek one pi and the Latin one p, so we can distinguish clearly. So we have pi and p. And make sure that the lowercase p is distinct from the lowercase rho. So rho and P in their lowercase form, they're often confused. So make sure they are distinct when you're writing them. Because rho, that can sometimes mean density, and P, that can sometimes mean pressure. And we don't want to confuse these different quantities because they are represented by similar looking letters. So try and make this form of this lowercase p look distinct from this lowercase rho. But the capitals are very hard to distinguish. So you have this capital rho over here and this capital Latin P. And that's why we don't use these as pairs, but we do use rho and P sometimes in the same equation when they have their lowercase form. San, we're just going to ignore because it's an archaic letter. Copa corresponds to the Latin Q, which is the same as the English Q. So here we have capital Q and lowercase q. So that corresponds to the Greek kopa. Then rho corresponds to the Latin er. Er is the same as the English r. So here we have capital R and lowercase r. So note that now we have an extra line over here, and that distinguishes the Greek rho from the Latin r. And the lowercase forms are very different. Now sigma corresponds to the Latin s. And we have the lowercase form and the uppercase form over here. Tau corresponds to Latin te, which is English t. And we need to make sure that the lowercase form is distinct. So tau and t in their lowercase form, they have to be distinct from each other because sometimes they're used in the same equation. Now let's have a look at this bottom row over here. Psi or psi, that is usually romanized as PS, like in psychology. So that's the start of psychology. So PS is the romanization of this letter psi. Chi is usually romanized as CH, like in chemistry. But chi also has a Latin counterpart. Chi can be thought of as analogous to the Latin ix. And the Latin ix is the same as the English x. So this is x over here. Make sure that your lowercase x is distinct from your lowercase chi. So these are sometimes used in the same equation, and we want to make sure that they are distinct letters that describe different mathematical quantities. Then phi is usually romanized as PH, like in physics. So here we have physics, chemistry, psychology. So these are the romanizations of these Greek letters, phi, chi, and psi. What about ypsilon? Well, the capital form looks like the English y. And when it entered Latin, it was sometimes called e graeca, like the Greek e sound. And that explains this capital form, and that's the English y. And this is the lowercase form for this English y, which would be e graeca in Latin. But there's also another Latin letter that can be traced back to ypsilon, and that is the Latin u. And the Latin u used to be written like this. So that looks like a modern V. It was only later that U and V became distinct letters. So we can write U over here. So U and V are distinct letters. And these are the lowercase forms. Make sure that when you write the lowercase v, it needs to be distinct from the lowercase nu. That's a common point of confusion between this nu and this v. V is sometimes used to denote velocity, and nu is sometimes used to denote frequency. These are different quantities. So we need to make sure that when we write this lowercase nu, it looks different from this lowercase v. And when you put two u's next to each other, that got turned into double u. So W has this form. And the lowercase w is often confused with the lowercase omega. So make sure that your lowercase omega and your lowercase w are distinct, because these are different letters. So this is a Greek letter, and this over here is a Latin letter. So the classical Latin pronunciations would be A, B, K, D, E, F, G, H, I, K, L, M, N, O, P, Q, R, S, T, U, and then we have X, and we also have Y, and finally zeta. But we've seen that there have been some changes, and now we're dealing with the modern Latin alphabet, and so I and J are distinct letters, and U and V are also distinct letters, and this W was also added. So U, V, W, and Y have a shared common origin with Y, and Y has a shared common origin with D gamma. They can both be traced back to the Phoenician letter Wow. So similarly, C and G have a shared common origin, and I and J also have a shared common origin. So the purpose of this video was to provide context and clarity. So make sure that you can clearly distinguish letters that have similar forms, because they are used to denote different mathematical quantities. So in the red, we have the old Phoenician alphabet. So it includes 22 letters. And in the black, we have the Greek alphabet. And in the blue, we have the Latin alphabet. And we've also shown some Romanized forms of these Greek letters that don't have a single letter counterpart. And some confusion might arise between this xi and this ki. So psi, as it's also called, and chi over here, the form of chi matches the Latin x, but the transcription usually favors x for this xi. So you could also maybe transcribe it as ks because it makes a x sound. So that's what this xi is. But this chi is usually transcribed as ch, even though the form of the letter closely resembles the Latin x or the English x. So you can see that the pronunciations of these letters have changed over thousands of years, and the pronunciations for modern Greek speakers are very different from ancient Greek speakers. So this beta is no longer pronounced like a B, it's closer to the English V. So this would be more like a veta. And some of the other letters have also drifted away from their original pronunciations. So you can see that we have a system where we have a sequence of letters that form an alphabet. And these letters can represent sounds. And in modern mathematical notation, we have repurposed these characters and we use them to symbolically describe quantities. And that allows us to symbolically reason. So hopefully this video provided some context and clarity for modern mathematical notation.